Okay, well, welcome to part three. We're almost done here, second to last video, so this should be pretty good. This is probably going to be the more exciting part of it because we're actually going to start training the network. But this is part two. We're going to be actually fitting the CNN to the images. Generally, usually when we do an ENN, we kind of do or sorry, a neural network. We kind of do it the other way around. We kind of pre-process the data first, and then we tend to classify it. And then since we have to augment the data that is before we send it through the network. Um, we essentially we build the layers first, and then we kind of send it through. So that's the reason why we do it like this. This is kind of a little bit of a data automation trick, what we call, in order to essentially prevent overfitting, which is a big problem with neural networks. Is the overfitting phenomenon, if you want to call it. Sometimes the models get too complex. It's a big issue with yeah, with in fact, it's a very big area of active area research about optimization and the what they call the bias versus variance types of trade-offs, and how we can, if a network or a machine learning model is learning the data too well, or classifying the data too well, it's picking up all the noise and stuff like that. There's ways that we can. There's lots of different ways that we can do to prevent overfitting. Probably the simplest way is just to kind of add more data, but sometimes that may not do it. Sometimes we don't have the data that we need. Sometimes the data can be scarce, and that's where generative models and stuff like that came in. Anyway, that's not what this is about. But in order to, like I said, in order to prevent the overfitting phenomenon, we have to apply a technique called augmentation. So this is what we're going to do now before we kind of train the network here. We have to, essentially what that involves is creating many batches of images, and in each batch it's going to create some random transformation of the images, and it's going to actually take the images of those, like dogs and cats I showed you in previous videos, and kind of rotate them, flip them around, shifting them. Literally, it's going to do this. It's going to kind of shift those pixels around, stuff like that, to kind of prevent from kind of memorizing, prevent the network kind of memorizing a set data pattern. So we need to use a specific library here that we're going to import here. The image data generator here, again from the Keras library. And essentially what this is going to do is this is for real-time, what's called real-time data augmentation, quote unquote. This is going to define the configurations that we're going to walk through here in a minute. Defines the configuration for the image data, preparation and augmentation. Okay. So with that, we go ahead and add this in, and okay, it's in. Okay, there it is. What we do here with the train data, it's what we're going to do is we're going to rescale the images, and each image goes in, it gets kind of warped and so forth like that. So we need to rescale it, and that's what these hyperparameters are going to do. It's actually going to share the image. These are some of the things that are actually going to happen to the data when it's going to actually, when this is shear, it's actually going to more or less, it's kind of hard to explain these things, but it's actually going to shift the image apart and stuff like that. And this hyperparameter 0.2, you can use different ones too. Each one will kind of give you a little bit of a different result. It might zoom in a little bit on some pictures at random and zoom out and stuff like that. I was going to hit here. It said like it's going to flip it. It's good. Do those kinds of things. So, and it's going to do all these things at random. So it's kind of hard to say, at this point it's going to do it. So that's kind of just just to kind of give you an idea what's happening here. When I use the taste, now we're going to go to the test datagen variable here, and again using the image data generator, rescaling the data that's been put through it. This creates an object to pre-process the image of the test set. This basically trains and evaluates the test data at the same time it runs through here. So we need to do this and make sure we have these in here. So highlight these, put these in here. And then here, when we train the data, we're going to use the train datagen variable and a function here, flow from directory. Make sure that you have the correct directory, whatever you have, file path name for these libraries that you had to download at the beginning of the program here. So very important that you have these, otherwise it's not going to work. Again, target size, make sure you put in the same parameters at the beginning. I think we use 64 up here. Okay, these are going to be the shapes now. So you have to make sure that this input data, the input shapes, we want to put these at 64 by 64. So it's very important that you follow suite here and that you put 64 here. And batch size, this is going to be the size of the actual batch, 32, before it goes back and reformats them or updates the weights and so forth. And of course, class mode is binary again. Now, when we get down here, this is where we're actually fitting, or we can actually say we're actually the actual training is going on here, where we use the fit function, fit generator function. Again, using the training set here, passing it in here. Samples per epoch. Epoch is just how much data that you have in like one data set. We call it an epoch. Well, we're using 8,000 epochs of it. At every 25th epoch, what's going to happen is that actually the weights and we call the parameters and the weights and the biasnesses are going to readjust, and that's essentially where the learning takes place. So make sure that you have all this set up and set in, and what we're going to do is going to highlight these, and we're setting it up here, and we have an error here. System cannot find path. Okay, so this is exactly what I was saying here about how there's a different type of problem here. Let me see. The system cannot find the path setup. Let's see here, data set here. Make sure that we have. Okay, and let's try that again. Is it? Okay. And right, so that's what we want. The 8,000 images, what it actually found, it had found to be 2 classes here. That's exactly what we want it to say. It shouldn't be 3 classes, it should be 1 class. It actually should be having 2 classes when it actually went through all these 8,000 images that we have. Okay, and that's good. That's exactly what we want here. Now, when we do this, when we set this going here, it's actually going to run through all these epochs of all these 8,000 images here, and you're going to actually see it go up, and the accuracy rating go up and go down depending on what epoch it's on, and how far it is through the data sample. Because it takes quite a while, and depending on the processor that you have, whether using, by the way, we're using a CPU, we're not using a GPU. GPUs are actually better for training CNNs because they have more cores that they can kind of delegate to training the data and sifting through the data. And GPU is the graphics processor unit, and that's actually known to be much better and faster for training visual data, video data, and digital images than CPUs. We're using the CPU, which is more of a direct route. It can focus basically on one thing at a time here, but it doesn't have as many cores, so it's not going to be as effective. But that's just to kind of save time here. So we're going to start this, and what we're going to do is we're going to stop the video. We're going to let it go through, and then after we come back and it's trained, we're going to actually do the actual classification. We're going to see how good it was. Okay, so just we're going to let this rip, and then we're going to be back, and then after it's trained, and then we're going to say, okay, so here it goes. Here it's going on the first epoch. Remember, after 25, it's going to start updating everything. And you can see the loss function. First, it's decreasing. And your accuracy looks like it's going up. Okay, just to show you, this is going to take quite a while, so just make sure that you have some time. But we're going to stop the video now, and then we're going to come back for the final part, and we're going to see how well we did with the classification, and then we'll just take it from there. Okay.